Hello everybody, welcome to week 2 session 4 of marketing analytics. This is Dr. Shagata Chatterjee from VGSOM IIT Kharagpur who is taking this course. We were discussing about the conjoint analysis, the application of conjoint analysis in the last video. We'll continue on that. So in the last video we have talked about something called pricing decisions, how pricing can be done through conjoint analysis. So, there are lots of other pricing models. We will discuss about all of those things in details when we go to the pricing part of our marketing analytics course in a different module, but in this module I am just giving a hint that pricing can be done also through conjoint analysis. So, another thing is brand premium. So, another major variable is brand premium. It is very easy. Brand premium, how will you find out? So, first of all, what is brand premium? A brand premium is nothing but basically the extra money that you are willing to pay just because there is a brand written on that. So, for example, let us say this is a water bottle which is non-branded water bottle. Now, for this non-branded water bottle, how much money you are willing to pay, that is your the money that you are willing to pay for this water bottle is basically for a non-branded product, whatever you are willing to pay. Now, just imagine on the top of this water bottle it is written that this is Bisleri. Everything remains same. You do not know what kind of water is there inside. You do not know what kind, whether the plastic is good or bad and etc. So, the only simple thing that is written on the top is Bisleri. Now, for that, keeping everything same, one is the same water bottle without any tag, any name, anything written, and you have not tested the water or whatever, the water is there, but you have not checked the quality of the water. The other thing is that there is a name written there. So, brand comes with certain kind of promises, brand comes with certain kind of trust, brand comes with certain kind of I would say quality expectations. So, all of these things, for all of these things you are willing to pay a little bit more money. So, for a non-branded bottle of water which I have just shown, you can probably pay how much? 1 liter bottle for 5 rupees at max. But the moment it gets branded, you are willing to pay probably for 1 liter bottle 15 rupees, 20 rupees, probably more than that. So, depending on the brand, the value of that particular water changes. It is a very commodity, it is a basic thing that we have, but still you are willing to pay more. So, that extra money that you are willing to pay more over and above something which is non-branded is something called brand premium. So, we can also find out the brand premium or probably that consumers are willing to pay or probably preference of the brands over brand A versus brand B when we talk about this conjoint analysis. How? Let us say in this particular table, instead of fuel, if by chance it was brand A, B and C, some brands, let us say A is let us say Maruti, B is let us say something else, Tata Motors, and then C is somebody else, some other make, I do not know, Ford probably. So, the moment it becomes A, B and C, I know that brand A is most preferred, brand B is lesser preferred than brand A. The difference between preference is minus 2.66 and brand C is the least preferred out of these 3 brands and the preference is minus 4.33. The difference between the brand preference of A and brand preference of C is minus 4.33. And by chance, if instead of rating, I told in the pricing decision, you can also ask willingness to pay. So, by chance, if you have asked willingness to pay and then you did the regression and got this result, then it does not talk, these 3 values does not talk about brand preference, they are directly talk about brand premium, how much extra money you are willing to pay. So, you are willing to pay 4.33 lakhs rupees, let us say if the unit is in lakhs, 4.33 lakhs rupees more when you get brand A versus brand C. So, instead of brand C, if I give you brand A, keeping every other thing same, you are willing to pay 4.33 lakhs more. So, keeping every other thing same, instead of B if I give A, you are willing to pay 2.66 lakhs more. So, that is something that is brand premium. So, you can also say A, B and unbranded, and you can directly get the brand premium. So, this is relative. The moment one of these things are unbranded, that becomes the absolute brand premium. The quick question, can you say that what is, if instead of C, if I give B, how much more or less you are willing to pay? If I say that instead of C, if I give B, if I give you B in terms of the brand, then how much extra you are willing to pay? So, it is basically for C you will pay minus 4.33, for B you will pay 2.66. So, if I instead of C, if I give you B, you will actually pay me more. How much more? This much more. Sorry, 4.66, 4.33 minus 2.66, this much more. So, that is the value of the brand premium of B in comparison to C. So, something like that we can also find out through this thing. So, I will just go back to the old thing. Yeah. So, that is how I can also find out brand premium, that is number 1. There is the second application of this conjoint analysis. There are other applications as well. Now, the third, and which is one of the most important application, is called the market share modeling. So, see, conjoint analysis is used to check that what kind of product combination. So, preferred, after knowing the preference, what will you do? Let us say you come to know that okay, this is the customer's preference. So what? This so what part becomes very important in marketing analytics. So, we are not data scientists. I will not just give you some data and say that do whatever you want with this data. I will always ask you so what. So, I have to be a business guy. I do not only have to be a number cruncher. So, here I am asking you so what. So, I am giving you certain preference, what will you do with that? Now comes, you have to put on your marketing cap and you have to say that okay, with this preference I will create a new product. So, I will say so what, you will create a new product, how will I know that this product will work or not work, how much should be the price, how much should be the, after you launch, how much should be the success rate and etc. So, you say wait, do not worry, I will give you that if I launch this much, what will be the expected market share of this product, how much revenue it will generate, how much profit it will generate, I will give you all those story. Okay, how? I will say just be with me, I will show you. So, to do that, the first thing that you have to do is find out how conjoint analysis can be used to find out market share. So, let us say I will do that. So, let us say I have 3 options in the market. Right now, I have 3 products, 3 competitors in the market who are already there. So, do not worry about this part right now, just focus on this part. So, let us say the first option is diesel with 6 capacity and 12 lakh price, second is petrol 4 capacity 8 lakh price and so on. Now, based on my equation that I have created, I find out their scores. What is the score that, or preference score that, or rating that the customer is giving if they have got this particular combinations. So, this is, you would just take 10 is the intercept and then for each of them you are taking the values. So, just correct me if I am wrong, probably I am right. So, 10 minus 2.4 is 7.6, 5.34 and 4.47. Correct me if I am wrong, or if you do your own calculations, but these are the expected ratings that the customers will give if the competitor 1, 2, 3 are presented in front of them. So, this is something that I get. Now, we make an assumption here. So, our assumption is that is the rating. So, I say that utility of this thing is basically rating to the power some alpha. So, rating to the power some alpha is something that I think is the utility that you get, and alpha is a coefficient, I do not know what that value is. And I also say, so basically utility and rating are related to each other, and I also say that probability that you will choose ith product is utility of ith product divided by summation of utility of all the products for all I. So, this is something that is an assumption. You can make many other assumptions. You can take, no, it will follow a logistic formula. So, it will follow e to the power ui by whatever to the power ui and so on. that is also okay. So, it as per your assumption, you will see that this will all fall in place. So, ui divided by summation of ui is something that I will do, and what is ui, which is rating to the power alpha. So, in this particular thing what I do is I assume an alpha. I do not know what is the value of alpha. So, for that I find out that this is the coefficient value that I have taken, and let us say the coefficient value is 5 to start with, okay, 5. I randomly have written 5. So, then what is the market share here? The actual market share is 45, 35 and 20, that I get from some market research. And if that value is 5, what is, if and all my equations and etc., if the equation that I have written here is correct, if I assume that it is to be correct and the value of alpha is 5, then the calculated market share comes up to be like this. Then the calculated market share is basically, for the first one you see carefully, E2, that means 7.6 to the power N2 means 5. So, 7.6 to the power 5 divided by 7.6 to the power 5 plus 5.34 to the power 5 plus 4.47 to the power 5 into 100, because we are putting it in a percentage term. So, 7.6 is the rating, R alpha, R to the power alpha, that means 7.6 to the power 5 divided by summation of all the R to the power alphas. So, 7.6 to the power 5 plus E3 means 5.34, 5.34 to the power 5 plus E4 means 4.47, 4.47 to the power 5. I find out the predicted market share, I find it for this one also, and I find it for this one also. The only thing changes is the numerator, the denominator remains same for all the 3 cases. So, this is my predicted market share, this is my actual market share, and they are different as per current form. How different? I just find out the square error. So, I should not have written error, it is square error. So, F2 minus G2 square. Similarly, here F3 minus G3 square, F4 minus G4 square, and this is the RMSE, which is average of these 3 and then square root of that. Root means square error. So, I calculate the square error, take a mean of them and then take a square root of them, I get 25.28. Now, you see in the whole story that I have created, the only variable here, ratings are given, rating is not variable, the only variable here is alpha. So, I have to find out the best possible alpha which will reduce this RMSE, that means which will make sure that the actual and predicted values are very close to each other, then these equations are correct. If I find out the best possible alpha where this predicted market shares and the actual market shares are closer, then my equation is okay to go ahead with to do further analysis. So, for that I will go and do a solver. So, here see the solver in the data tab in Excel, the solver thing is not there. So, for that what I have to do, I have to go to files, options, add-ins, and here there is a Excel add-in. So, I will click on that and I will just click on solver add-in and then press check solver add-in, press OK. So, carefully see what I have done it, and then you see that here solver comes. So, if you could not follow me, pause, go back to probably 4, 5 or 10 seconds, 15 seconds, and you will know that what I have done, and this solver is there right now. So, what I do is I go to solver and I say that solver, you have to set an objective here. So, I say solver, minimize this H5. So, H5 I have selected here, minimize this by changing what? N2, by changing N2, and make, in most probably your solver it will be checked, make unconstrained variables non-negative. What is unconstrained variable? What is variable here? N2 is the only variable that changes. So, you make it non-negative, if you check it, it will be always positive. I do not want to do that, I want alpha to take any value, positive, negative, any value. So, let it be. So, I just ask it to solve, and the moment it solves, it gives me 1.221, something like that, 1.2209, which gives me RMSE very low, and these values are more or less similar, not exactly similar, but more or less similar right now. So, 1.221 is something based on which. Now, if something else happens, if you find out some other competitor, then I can find out how the market share calculation can be done using the similar formulas that has been reported here. That is number 1. So, market share modeling is done. Now, if you do a new product introduction, I was asking you that I will always ask you, so what? So, if you do a new product introduction, what will you do? So, let us say you have these 3 competitors again. I will come back to this thing. You have the same 3 competitors, same 3 scores, and instead of 5, I have used 1.221 as my alpha value directly, and if I calculate 1.221, it is coming 46.02, 29.91 and 24.07 as 3 market shares of competitor 1, competitor 2, competitor 3 as per the formula currently. Now, I as a competing company where competitor 1, 2, 3 are my competition, I have 3 options in my hand. I can either come up with this, either come up with 2 or come up with 3. Corresponding scores are given. Now, you can directly say that okay, this score is high, I should go for this score obviously, because as scores goes up your market share goes up. So, you should go with this score. Why we are doing all the maths? Because as I told you before that scores are related to, so if you remember, scores are related, what we are trying to do, the customer is trying to do this, customer is trying to do maximize V minus P, something like that. And what I am trying to do? I am trying to do maximize D of P, that means demand as a function of price into basically price minus cost. So, I will not always choose that option where the V is the highest, because for that V this cost is a function of V actually, how much V I am trying to produce them. So, if V goes up, my cost also goes up. So, that will reduce all the whole kahani. So, we have to find out that what is my optimal, and using lots of things. I have to consider cost, I have to consider the probably how much extra benefit that I can give, how I can change something that I have available with me, what will be the demand function, and etc., etc. All of many years things together will actually decide that which options. But one step of that, the first step of that is to find out the market share for option 1, market share for option 2 and market share for option 3, because at least I will know the demand by doing that. Then I have to optimize lots of stuff. Cost part we are not bringing in right now. So, we will bring it later. We are just trying to find out that how to maximize the, how to find out which one gives the how much market share, that is all. That is my job here. The rest of the part, which one, considering the cost, considering the innovation, etc., etc., is a different ball game. It is another mathematics we have to do, which is beyond conjoint analysis, but you should do that at a later point of time. As I was telling that it is, any marketing decision is actually a combination of lots of marketing decisions taken or lots of small analytics done sequentially or parallelly sometimes. So, this is one part. Then you find out the cost part, how, what is the cost when you give this, what is the cost when you give this, and so on. And then you combine the market share and the cost and the price together and run an optimization, which is another analytics, to find out which is your best option. Right now we are not going up to that level, we are just asking you that how much will be the demand if I go for option 2, option 3, option 4. So, I do the same thing, the same maths, but in the denominator, in the when I, so this G column is about when option 1 is introduced, H column is when option 2 is introduced, and I column is when option 3 is introduced, and I am not introducing all the 3 things or more than one options together. So, when I introduce option 1 only, the only thing that comes extra is this part. So, E8, that is 10 into 10 to the power 1.221 in the whole story, and I calculate the market share for this, this, this and this, and similarly I do it for option 2, these 3 guys and this, and these 3 guys and this. So, I can clearly see, obviously for 10.2 the market share will be the highest, 39.73. For 10 it is also pretty cool, and 6.14 it is smaller. That is okay, that is obvious. What I also want to mention is, just see that who is getting affected most. You will see that the guy who is probably getting affected most in this case, in this case, where petrol 446.14 I am getting 26, for all of this case I am actually taking up 46.02. So, here from here it is coming up to be 28, here it is coming up to be 27. So, almost a drop of 18-20% market share, but here this guy is dropping probably only 10% or 11%, and here not even that, 7%. So, the jump, whenever you come up with something which of a higher score, the most the biggest guy, the highest most guy will get affected, and that is something that we are trying to represent here. And then based on many other factors, we will try to find out that which combination is better than other one. So, till now we have talked about, for a rating based, what kind of works you can do. So, there are other kinds of conjoint analysis also. In the last class we discussed about that a little bit. There is something called choice based conjoint, and there is something that I have not discussed, which is called adaptive or hybrid conjoint. So, choice based conjoint is different from this conjoint, because there you do not give all the options, 27 options or 9 options, 10 options together and ask them to rate. Rather than in choice based conjoint, you give 3-4 options in each set, choice set, and then so we also do this kind of decision making. If you remember, in marketing there was awareness set, consideration set, choice set, and then choice. So, before you make a choice, you create a choice set. So, here I am giving you the choice set. So, if the choice set is like this, which one will you choose? So, I give you 10-15 choice sets depending on the overall number of options available, and you choose. Now, that is a 1-0 decision, or probably multinomial decision, choice 1, choice 2, choice 3, choice 4, and we do conditional logic. We will talk about that. Conditional logic is, given this choice, which one you will choose, that kind of a logic function. We try to estimate that and find out the options. So, that is number 1, that is something that we will do in the next video, and then we will also talk about, basically I am not going into detail of that, but there is adaptive conjoint, where it says that not all options are very distant from each other. Some options are actually very close to each other, and some options are very differentiating. So, it is very important to find out that which of the options are differentiating from each other. So, remember in GRE exam or many other online exams, the questions that comes up are actually trying to find out they are adaptive in nature. As you give good answers, they try to give you more hard questions or something like that, so that they find out in the whole normal curve where you are fitting exactly. So, here it is similar kind of operations are done, where based on your responses that you are giving, I try to find out the minute details between probably category A and category B, and the more you give the results, the responses which are closer to each other, I try an adaptive mechanism to give you certain options which are closer and ask you to differentiate them. So, that is an adaptive mechanism which is used in only this can be used probably successfully in an online environment. In offline environment it does not work, because you cannot do that maths like this. So, that is one thing, that is another option that you can adopt. So, these are all about conjoint analysis. In the next video we will talk about the choice based conjoint, and we will talk about a little bit of choice modeling first and how to solve a choice based conjoint. Hope you have enjoyed this particular video, where I have shown lots of applications of conjoint analysis in marketing problems. We will continue in the next video. Thank you.